Okay, so now we've reached the example where we're going to find the sum, partial sum of a geometric series with sigma notation. Now, unfortunately, unlike the arithmetic series, where we can actually just get on our calculator, pull up the sigma notation, fill in the numbers in the appropriate blocks, hit enter, and spit out an answer, this one is a little bit more complicated. So before we look at the sigma notation, let's first then look at what our how we're going to use this partial sum formula. And if you go back to the previous video, you may recall I talked about factoring out the A1 so that I could have the sum of the series equals A1 parentheses 1 minus r to the nth power over 1 minus r. So now let's take a look here at the sigma notation, and let's talk about what this means. So this k equals 4 really means that beginning with A4 through A12, this is the sum of the geometric series that we are going to calculate. Now, this part right here, 1/4 times 3k over 1, is our formula for finding the fourth term of the series. So what we're first going to do is we are going to plug in 4 for k in this 1/4 times 3k, 3 raised to the power of k minus 1, and that's going to give us the fourth number in the series. Okay, so let's do that. And okay, I'll come right down here. Where do I want to do this? Because I'm going to run out of room for sure. I'll go up top here and do this. So we got 1/4 times 3 raised to the power of k minus 1, and that's going to equal 1/4 times, in this case, 3 to 4 minus 1, 3 cubed. Okay. So let's see. Well, 1/4 times 3 cubed. 1/4 times 3 cubed. And we're going to call this A4. How about this? A4. 1/4 times 3 cubed, which is 27. 3 times 3 times 3. 3 times 9 is 3. 3 times 3 is 9. 9 times 3 is 27. And so A4 is going to equal 27 over 4. Now, we can use this and substitute it in for A1, not being the first number of the series, but the first number, well, not the first number of the sequence, but the first number of the series. And we're going through A12. So let's see. Let's begin to then plug this in. Thinking about how I want to do this because I'm still going to run out of room. I'm going to start coming back down here. So I've got Sn equals 27 over 4 times 1 minus r. All right, and we got to raise it to the nth power. And so what is n? Well, you might first think it's 12. But it's not 12 because we're going from 4 to 12. And so then your next step might be, well, okay, well 12 minus 4 is 8. We'll raise r to the power of 8. And if you did so, you would be wrong. So let's think about this. All right, we got a to the 4th, a fourth term in the series, plus a5, plus a6, plus a7, plus a8, plus a9, plus a10, oh, I'm running out of room, plus a11, plus a12. Now, that would actually be the sum. If we were to calculate all of that, that would actually be the sum, and I certainly don't want to do that by plugging every one of those into that. That just seems like just a whole lot of work. But let's look here. How many numbers do we really have? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So while we might be inclined to think 12 minus 4 is 8, really what we've got is 12 minus 4 plus 1 equals 9. So when we're looking here at sigma notation, we're going to take the number on top of the Greek letter sigma, 12. We're going to subtract k, or whatever variable it is, for what's below sigma. Subtract those and then add 1. So coming back here, so we're going to have r to the 12 minus 4 is 8 to the 9th power over 1 minus r. All right, so let's plug in some numbers. I'm going to go this way here for a while. So now we got 27 over 4 times 1 less, and let's see, r, here's r. We pick up r from that coefficient right there. So we got 3 to the 9th power over, and 1 minus r, well, I'll write it out, 1 minus 3. Okay, that's going to equal, I'm going to go down here below, and so I've got Sn equals 27 over 4, parentheses, 1 minus, all right, 1 is 3 to the 9th power. 3 caret 9, 19,683. 19,683 over -2. Whew, this is going to get nasty. So I think for the space, I'm just going to put this into the calculator. Listen to what I am doing. Put in parentheses 27 over 4. I'm going to close my parentheses. Times, so let's see, 1 minus 19,683 is going to give me negative 19682. So I'm going to go times 19682, close that parentheses, 27 over 4 times 19,682 is going to give me negative 265,707, 265,707 over 2, but all of that is over -2. Man, what a mess. Okay, so if I take negative 265,707 over 2 and divide it by -2, that's going to be the same as, I think I will, so I'm just about out of space. We'll go right here and we'll go negative 265,707 over 2. And that's going to be, dividing by -2 is going to be the same as multiplying by -1/2. All right, let's see what all that does. Okay. So that times 1/2 equals It's 265,707 over 4. And let's see if we can't get that to a decimal. Yes, we can. And so that is then going to equal, and this will be our answer, 66,426.75. Now, if you don't think this is fun, you just aren't living. What a hideous mess. Okay, what do you say we knock this one out and see if we can't get this one over as soon as possible and go on our way and find something else we can solve? Horrible. Okay, so here we got sigma. We got a 9 on top of the Greek letter sigma. We got k equals 2. And we've got our geometric little formula here, which is 2/3 times 4 raised to the power of k minus 1. And we're going to substitute 2 for k. So let's go up here. So we're first going to find A2, second number of the series. And so we got 2/3 times 4 raised to 2 minus 1. Oh, that's just 1. So that's going to equal 2/3 times, well, 4 to the first power is just 4 times 4. And 2/3 times 4 is going to give us 8 over 3, or 8/3. Now, we can now plug this into our partial sum formula. So let's go Sn equals, well, we're going to use A1, the second number of the series, which is going to be the first number, second number of the sequence, which is going to be the first number of the series. And so we got 8 over 3 times 1 minus, and there, right there is our R, that's our common ratio. So we got 4, and what are we going to use for n? Well, we got 9 minus 2 plus 1. We went over this in the last slide. So 9 less 2 is 7, plus 1 is 8. So we're going to raise 4 to the 8th power. And this is going to be over 1 minus 4, or negative 3. All right, so let's see. Sn then is going to equal 8/3 times 1 minus, oh my goodness, 4 to the 8th power. That's got to be a hideous, hideous number. 4 caret 8. Well, it wasn't as bad as I thought. 65,536. Bad enough, isn't it? 65,536. And that's over, well, that's over negative 3. All right, so Sn equals 8/3 times, okay, 1 less 65,536, then is going to give us negative 65,535. And that's going to be all over negative 3. We'll move over here to the left since I keep running out of room. So I got Sn equals, okay, so what's 8/3 times negative 65,535? I'm going to hit parentheses, 8 over 3. I'm going to close my parentheses. I'm going to multiply that, and I could just hit another parentheses. I'm going to hit parentheses, negative 65,535, close my parentheses, hit enter. And so now I've got negative 17,476. 17,476. I don't think I got something off here. 65. Oh, well, I see what I did. I did it 8 over 30. I knew something was wrong. Let me go back. Parentheses, 8 over 3. Close my parentheses. Parentheses, negative 65,535. Close the parentheses. Hit enter. And that is negative 174,000, negative 174,760, and that is over negative 3. So we got negative 174,760, and we are going to divide that by negative 3. And that is going to give us 58,253.333. So SN is equal to 58,253.3, and that is repeating. Oh man, I'm glad I don't have to do that for a living.